Welcome to the DIY Honda Garage channel. The error code B1826 pertains to a front height pulse error in the 2011 to 2017 Honda Odyssey. This code indicates a malfunction in the front seat's height adjustment system, specifically signaling that there has been no change in pulse for over 1 second when the seat height is being adjusted. The pulse signal is crucial for the operation of the power seat system. It usually originates from a position sensor that monitors the seat's vertical position and informs the control unit. This malfunction can significantly impede the functionality of the power seat adjustment system, affecting the driver and passenger seating comfort. Identifying the root cause of this error is essential for restoring proper functionality to the height adjustment controls of the vehicle. DTC B1826 indicates a front height pulse error, signaling issues within the power seat adjustment system. This system utilizes a position sensor to relay the seat's height status to the control unit, enabling adjustments. The key components involved are the power seat control unit, linked to the front up-down motor, and the position sensor that monitors the seat's height. These components are generally located under the driver's seat and can be accessed by removing the seat itself for inspection. If the front up-down switch is operated while the seat is at its maximum height or lowest point for more than 1 second, this code may be stored, indicating a fault even if the components are functioning correctly. It is essential to understand this mechanism to troubleshoot effectively and ensure proper seat operation. The possible causes for triggering DTC B1826 can range broadly across various electrical and mechanical issues. Loose or poor connections within the power seat adjustment system are a frequent culprit, as they can disrupt the flow of data between the control unit and supporting components. A faulty position sensor could also lead to this error, as it is responsible for sending accurate signals regarding the seat's height. Additionally, a malfunctioning power seat control unit may fail to process and respond to inputs correctly, leading to fault codes. Sometimes, this error can appear temporarily, hinting at sporadic wiring issues or intermittent failures that resolve on their own. It's crucial to conduct systematic checks to accurately identify the root cause. The symptoms associated with DTC B1826 primarily involve the malfunction of the power seat adjustment mechanism. Drivers and passengers may find that the seat does not move up or down, significantly affecting comfort and driving posture. Additionally, there may be scenarios where the seating position erroneously adjusts, leading to an uncomfortable driving experience. Often, the DTC indicator on the dashboard will illuminate, prompting the owner to investigate further. It is important to note that the symptoms can manifest inconsistently, suggesting underlying issues with electrical connections or components that need thorough inspection. Recognizing these symptoms early can help prevent additional damage to the power seat assembly. The first step in troubleshooting DTC B1826 involves clearing any existing diagnostic trouble codes using the Honda Diagnostic System, HDS. The HDS is a specialized diagnostic tool designed to communicate with the vehicle's onboard computer systems for comprehensive diagnostics. By clearing the DTCs, you can reset the vehicle systems and prepare for a fresh check for current error codes. It is essential to ensure that the HDS is correctly connected to the vehicle's OBD2 onboard diagnostics port before initiating this process. Following this step ensures clarity in diagnosing the next possible issues, particularly if the code reappears after the initial clear. This procedure lays a solid foundation for subsequent troubleshooting steps. In the second troubleshooting step, the ignition switch must be turned to the lock position and then back to the on-to position. This process reinitializes the vehicle's electrical systems and allows the power seats to reset. The on position is crucial as it powers up all electronic systems, including the power seat controls. After performing this action, you should be prepared for the next steps where you will operate the power seat adjustment switch. This reset is an important prerequisite in eliminating possible glitches in the system and ensuring proper functionality is retained. Remember, a well-functioning ignition mechanism is vital for the overall operation of many vehicle components. In this step, the power seat adjustment switch must be operated for several seconds in each direction. This action tests the motor's response to signal inputs. Ideally, engaging the up and down positions will prompt the front up-down motor to run smoothly, confirming that electrical signals are appropriately processed. As per diagnostics, DTC B1826 is relevant when the front up-down switch is utilized for more than 1 second while the seat is at its limit. If the seat does not respond as expected, further investigation into the motor's performance is warranted. Recognizing changes in pulse during this operation is crucial, as it will indicate whether the motor and associated sensors are functioning properly. Accurately monitoring these operations can lead to significant insights into the fault's nature. After operating the power seat adjustment switch, the next step is to check for any diagnostic trouble codes, DTCs, again, using the Honda Diagnostic System, HDS. This step identifies if DTC B1826 persists or if any new codes related to the power seat mechanism present themselves. It is essential to determine whether the issue is ongoing or merely an intermittent glitch. If DTC B1826 is indicated again, this suggests that the pulse issue is indeed a malfunction requiring additional investigation. Alternatively, if the DTC does not appear, it may imply transient issues, allowing you to explore possible electrical connection problems further. Clarity in this step is pivotal for moving forward with a targeted approach that focuses on specific diagnostics. In this step, you once again check for any diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. It is crucial to see whether DTC B1836 also appears, as this code may indicate a related issue in the power seat control unit. As a technician or mechanic, if B1836 is detected, it suggests that further troubleshooting of that specific code is necessary. This indicates that the problems may not solely be related to the front height pulse, but may encompass broader issues affecting the power seat adjustment system. If DTC B1836 does not show, this allows you to advance to subsequent troubleshooting steps aimed directly at B1826. This organized approach systematically narrows down the fault, increasing the likelihood of an accurate diagnosis. Step 6 involves checking for any additional DTCs again through the Honda Diagnostic System, HDS. In this instance, you must look for codes such as B1825, B1827, or B1828. The presence of any of these codes can hint at associated faults within the power seat system. If any of these DTCs appear, further steps will need to be taken to resolve those codes, as they can indicate specific both electrical and mechanical malfunctions impacting the power seat functionality. If none of these codes are indicated, you will proceed to the next step, focusing solely on DTC B1826. This careful documentation of any new DTCs helps build a comprehensive view of the issues present within the power seat system. In the 7th troubleshooting step, the ignition switch should be turned to lock 0, followed by cycling it back to the on 2 position. This action serves as a reset for the vehicle's electrical systems. particularly focusing on those associated with the power seat assembly. Resetting the ignition ensures that the electronic signals governing the power seat operation are operable. Subsequently, this procedure aids in determining the system's current status, as electrical components often benefit from a reset to clear temporary issues. It is crucial to ensure that this process is carried out correctly, as the accuracy of this reset can significantly influence the diagnostic outcomes in the ensuing steps. Step 8 focuses on operating the front up-down switch for 2 seconds while monitoring the front up-down motor's operation. This process is critical, as it allows you to assess the motor's performance directly. Whether the motor runs smoothly or exhibits irregular behavior will provide valuable insights into whether electrical issues or mechanical failures are present. If the front up-down motor operates without problems, it indicates likely functionality in the associated wiring and connections. However, if the motor does not run smoothly, further diagnostics will be needed, potentially indicating more significant faults in either the motor itself or its related sensors. Understanding how the motor operates in this step allows for focused troubleshooting in subsequent sections. In this step, the ignition switch is turned to the lock position, followed by the disconnection of the power seat control unit connector B, which has a 40-pin configuration. You will also disconnect the front up-down motor and position sensor, identifiable by their 5-pin connector. This disconnection is an essential step to isolate the issue and conduct further checks without interference from the electronic systems. By separating these components, you can check each individually for faults or inconsistencies. Practicing caution during this procedure is vital to avoid damage to the connectors when pulling them apart. Understanding the layout and connections is crucial before proceeding to test wiring and continuity, as it sets the stage for more defined diagnostics. In the 10th troubleshooting step, the focus shifts to examining the continuity between the various connectors involved in the power seat system. Specifically, you'll measure continuity between power seat control unit connector B terminals number 9 and number 32, and front up-down motor position sensor 5P connector terminals number 1 and number 2, respectively. Ensuring continuity means verifying that electrical signals can properly travel through the circuit without interruptions. Lack of continuity could indicate damaged wires or faulty connections requiring attention. A multimeter may be used for these tests, making it easier to ascertain whether the wiring harness is intact or if repairs are necessary. Understanding which terminals correspond to specific functions is critical in this assessment to identify any faults promptly. After completing the diagnostic steps pertinent to DTC B1826, it's critical to conduct a final repair verification. This step ensures that the power seat adjustment system functions without intermittent failures, confirming that all identified issues have been resolved. You should closely monitor the system to ensure there are no returning DTCs, indicating proper functionality. A successful test drive can also help ensure that the adjustments respond correctly. It is essential to advise the vehicle owner to report any recurring issues immediately. This final verification provides peace of mind to both the mechanic and vehicle owner, ensuring that the power seat is operating efficiently. Preventive maintenance plays a vital role in ensuring the ongoing functionality of the power seat adjustment system. Regular checks of all electrical connections are essential to detect wear and tear before they lead to significant issues. This includes inspecting connectors for corrosion and ensuring that all wires are intact and securely connected. Additionally, routinely testing the power seat adjustments during vehicle servicing can preemptively identify malfunctions, allowing for necessary repairs before they escalate. Encouraging vehicle owners to utilize the power seat system periodically can help prevent stiffness in the adjustment mechanism. Understanding the importance of proactive maintenance not only extends the life of the power seat system, but enhances overall vehicle safety and comfort. In conclusion, troubleshooting DTC B1826 involves multiple steps aimed at identifying the root causes of the front height pulse error in the Honda Odyssey. Technicians must utilize the Honda Diagnostic System to clear and check for DTCs, operate switches, and ensure continuity in the relevant electrical systems. Understanding that loose connections, faulty sensors, or control unit malfunctions could lead to this error is essential in diagnosing effectively. Regular preventive maintenance can further uphold the functionality, assisting in avoiding future issues. Ultimately, a systematic approach aids in pinpointing the cause of the problem, reaffirming the vehicle's reliability for safe operation. Engaging in proper repair steps and preventive actions ensures a reliable driving experience. Please like and subscribe to the channel. See you next time!